In this video, we're going to be working with systems of equations again. This is part 2 in our Solving Systems of Equations series. And this time we're going to be solving these systems of equations using a method known as substitution. And we should already be familiar with the term substitution because this is when, if I have, let's say, 3x and x equals 4, well, that means we take this 4 and we substitute it into the x. So that would be 3 times 4, which would give us 12. We're going to be doing something very similar with our systems of equations today, using that substitution method where we know the value of one variable and we are going to plug it into the other equation. And we can do that because in systems of equations, we know that these two equations are linked together somehow. So let's get started. I have over here y equals 2x and y equals x. Now, what do we know about these equations? Hopefully, what we notice is that both of them are equal to y. And since they're both equal to y, their y's must be exactly the same. So what I can do, and I have two options here, is since I know y equals 2x, and y also equals x plus 5, I could take this 2x and I can substitute it into that y. And that would give me the equation 2x equals x plus 5. And as you may have noticed, my y's are now gone. That will happen in the substitution method. You substitute one value of a variable for what it is worth, and then that variable disappears. Now, the other way we could have handled this would have been if I were to, let me erase this. Okay, so I have y equals 2x. Instead, I could have taken the x plus 5 down here, and I could have substituted this into the y up there. But notice, if I did that, I would have x plus 5 equals 2x. And these two equations right here, this equation in blue and this equation in red, they're exactly the same. They're just flipped around on the equal sign. So you'll get the same answer no matter what. So we're going to stick with our first one, which was in red, and we want to solve for x. I know 2x equals x plus 5. Well, if I'm going to solve for x, all my x's have to be on the same side of the equation. So I'm going to subtract x from the right to get rid of it on the right, and that's going to subtract 1x on the left. 2x minus x is single x, just 1, and that's going to equal 5. So I now have the first part of my answer. X equals 5. And when I create my coordinate, that is the solution, my x-coordinate will be 5. Now I can take this x equals 5, this solution, and I can substitute this into either one of our original equations. It doesn't matter which one we use. It'll give us the same answer anyway. If I put it into the top, I would have 2 times 5, which is 10. If I put it into the bottom, I would have 5 plus 5, which is also 10. And that's the value for y, because both of those are y equals, so our y equals 10. Our solution then is the coordinate 5, 10. And this is where, if we were to graph these lines like we saw in the previous video, if we were to graph them, this is where those lines would intersect, 5, 10. Pretty neat. Okay, let's try a couple more, see how we can do this, and see if they get any trickier. Here is our new system of equations. Our top equation is x equals 2y minus 4, and our bottom equation is x plus 8y equals 16. Now think to yourself, why is this a great candidate for the substitution method, because that's going to be part of your struggle, is once we know all the different methods, when should I use which method? This is a great candidate for substitution because if we look at the top equation, we are told x equals something. We don't know what that something is, but we know x is worth 2y minus 4. So since we've already solved for x, I can take this 2y minus 4 and substitute it into the x in the other equation, which means I will have 2y minus 4, and this is all just the original x, plus 8y equals 16. Now I have a multi-step linear equation that I just need to solve. I want to combine all of my y's. I have a positive 2y plus 8y, so that gives me 10y minus 4 equals 16. I'm going to add 4 to both sides so that I get my y term alone. That's going to give me 10y equals 20. And lastly, I will divide by 10 so that the y is completely isolated, and we end up with y equals 2. There is my solution for y. In my answer coordinate, I don't know what x is yet, but I know my y coordinate is 2. Now, as you probably can guess, we're going to take y equals 2, and we're going to plug it in to y in either of these equations. It does not matter which one we use. I can use the top, or I can use the bottom. Let's use the top just to make things a little bit simpler. The top is x equals 2 times y, and we know y is 2 now, minus 4. Well, what is 2 times 2 minus 4? 2 times 2 is 4. 4 minus 4 is 0. So our x is 0. And there is our solution, 0, 2. That solves our systems of equations up here, and that is the point where our lines intersect each other. Pretty nice. Now let's do one more that's a little bit tougher and see what we come up with. In our final example here, we have the following system of equations: 2x plus 4 equals 2x plus y equals negative 4, and x plus y equals negative 7. Now looking at this, it might not be the best example for a substitution method problem, because if we notice, nothing is equal to a single variable. I have 2x plus y equals, I have x plus y equals. So it's not going to be as simple as the examples we've done previously, where we just had one variable equals and then everything else. But that doesn't mean we can't use substitution to solve it. What we're going to need to do, though, is solve one of the equations, whether it's the top or the bottom. We need to solve one of these equations for one of the variables. We could solve the top for y pretty easily, and we can solve the bottom for x or y pretty easily as well. And it all depends on your preference. It doesn't matter which one you choose. I would not try to solve the top for x, though. And the reason for that is then you're going to be introducing some fractions into your equation. It's going to make it a little more complicated. It's doable, but if we want the most efficient route, we aren't going to want to do that. Now, I'm going to take the top equation and I'm going to solve it for y. So I'm going to rewrite it over here. So if I'm going to solve for y, I need to get rid of the 2x, so I'm going to subtract 2x from both sides. That's going to give me y equals negative 2x minus 4. This is the same equation as originally, it's just rearranged. And what's important is now I have it solved for y. So I can take y equaling negative 2x minus 4, and we are going to substitute that in to the bottom equation. So instead of having x plus y, I now have x plus the value for y, which was negative 2x minus 4. This was our original y value. And this is going to equal negative 7. Now it's a matter of combining like terms and solving for x. If I combine like terms, I have x, and I have a negative 2x. That's going to give me a negative x minus 4, because I have nothing for the negative 4 to combine with. And this is going to equal negative 7. To get x alone, I'm going to need to add 4 to both sides, so plus 4. That's going to give me negative x equals a negative 3. And then we have to remember, I never want my answer in terms of a negative variable. I always want it in terms of the positive variable. So I'm going to have to divide by a negative 1, and it turns out that x equals a positive 3. So in my answer coordinate, my x value is 3. Now I have options like before. I know x is 3, and I can put it into this equation, or this equation, the one we rearranged. And I would recommend this because I already know y is equal to negative 2x plus minus 4. So I'm just going to take this x equals 3, and it's going to go in for x there. So I have y equals negative 2 times x, which is 3, minus 4. Y equals negative 6 minus 4. And lastly, when I combine my like terms, y equals negative 10. So our y value is a negative 10, and we have our solution. And that's it for solving systems by substitution. You always want to take one variable, have the equation solved for that variable, and then substitute that variable's value in to the second equation and solve. Hope this makes sense. Hope you are able to use this to help you, and good luck.